Hello and welcome to the Vodcast about the atomic theory for the first 20 elements. First of all, we're going to talk about an atom. And you can see there are two major parts of the atom. There's the nucleus and the electron shells. Inside the nucleus there are neutrons, and neutrons have a neutral charge and a relative mass of 1. Then we have electrons, and the electrons are found in the electron shells, have a negative charge and a relative mass of 0. And finally, we have protons that are also found in the nucleus, have a positive charge and a relative mass of 1. Before we get on to the elements, there are a few things we need to discuss. The first one is the atomic number. The atomic number is the number of protons, and it's always the smaller number on an element. Then the larger number is called the mass number, and the mass number is the number of protons plus the number of neutrons. Therefore, to work out the number of neutrons, we need to subtract the atomic number from the mass number. And in this case for helium, the number of neutrons is 4 minus 2, which equals 2. Last of all, we need to think about the number of electrons, and the number of electrons equals the number of protons if there is no charge on the atom. And in this case, there's no charge, so if the protons were 2, the electrons must be 2. Next, we're going to talk about the electron configuration. Electrons are housed in shells, and the shells are found around the nucleus. The higher shells have more energy than the lower shells. The electron configuration is how the electrons fill the shells around the nucleus. The lower shells are filled before the higher shells. The first shell can hold 2 electrons. The second shell can hold 8 electrons. The third shell can hold 8 electrons, and the fourth shell can hold 2 electrons. The stars mean that after 20 elements, the third and fourth shells can hold more than 8 and 2 electrons respectively. And so how do we work out the filling of the electron shells? Well, you need to think about having the number of electrons in a cup, and you pour the electrons from the cup into the cascade that I've got shown here. The first shell can hold 2 electrons, and as the first shell fills up, it overflows. The second shell can hold 8 electrons, and as the second shell fills up, it overflows. The third shell can fit 8 electrons, and as the third shell fills up, it overflows. And then the fourth shell can hold 2 electrons for the first 20 elements, and then this shell just fills up with the 2 electrons. Now let's first consider helium. Helium has an atomic number of 2 and a mass number of 4. From this, we need to get the number of protons, the number of neutrons, the number of electrons, and the electron configuration. So for protons, the atomic number is 2, so the number of protons must be 2. The number of electrons, because helium is not charged, the number of electrons equals the number of protons, and therefore it's 2. The electron configuration is just 2. The very first shell fills up with the 2 electrons. The number of neutrons is 4 minus 2, which equals 2. And then the diagram we can see, in the nucleus you've got 2 protons and 2 neutrons, and then you've got 2 electrons in the first electron shell around the outside. Then let's consider beryllium. It has an atomic number of 4 and a mass number of 9. Again, we're going to find the number of protons, the number of neutrons, the number of electrons, and the electron configuration. Right, with the atomic number of 4, it must have 4 protons. To work out the number of neutrons, it is 9 minus 4, which equals 5. Because beryllium is uncharged, again, it has the same number of electrons as protons, which is 4. And the electron configuration is 2, 2. And now here's the diagram of beryllium that shows 4 protons in the nucleus, 5 neutrons in the nucleus, 2 electrons in the first shell, and 2 electrons in the second shell. Now let's consider fluorine. 919 fluorine. It's a halogen, group 7. It has an atomic number of 9, therefore it has 9 protons. The number of neutrons is 19 minus 9, which equals 10. The number of electrons is the same as the number of protons because the atom is uncharged, so therefore 9. The electron configuration is 2, 7. And in the diagram here, we can see that we've got 9 protons and 10 neutrons in the nucleus, and we've got 2 electrons in the first shell and 7 electrons in the second shell. Now let's consider sodium. 1123 sodium. Now you see the number down the bottom, the mass number is not exactly 23, and that's due to the fact that sodium has several isotopes. An isotope means that it has the same number of protons but different numbers of neutrons, and the mass number relies upon the relative abundance of all these isotopes. But in this case, we're going to consider sodium has a mass number of 23. So the number of protons is the atomic number, which is 11. Number of neutrons is 23 minus 11 is 12. The number of electrons, because sodium is uncharged at this stage, is 11. And the electron configuration is 281. So in the diagram, we can see that we've got 11 protons and 12 neutrons in the nucleus. We've got 2 electrons in the first shell, 8 electrons in the second shell, and 1 electron in the third shell. The electrons in the outer shell are called the valence electrons. So here sodium has 1 valence electron. Then we'll move on to phosphorus. 1531 phosphorus. The number of protons is 15. The number of neutrons is 31 minus 15, which is 16. The number of electrons is 15, and the electron configuration is 285. In the diagram, we can see 15 protons and 16 neutrons. And the electron configuration is 2 in the first shell, 8 in the second shell, and 5 in the third shell. Then we're going to get on to element number 20, calcium 2040. So the number of protons is 20. The number of neutrons is 40 minus 20, which is 20. The number of electrons for this uncharged atom is 20. And the electron configuration is 2882. So if we look at the diagram, we've got 20 protons and 20 neutrons in the nucleus. And then we've got 2 electrons in the first shell, 8 electrons in the second shell, 8 electrons in the third shell, and 2 electrons in the fourth shell. Thank you for paying attention. Don't forget to like and subscribe, and I'll see you later. Bye now.